Welcome to Brain Vision.
We're told that we have a photon with an energy of 2.2 electron volts. I call this energy E gamma because gamma a lot of the times is the symbol that's used to represent photons. And it's absorbed by a hydrogen atom. To find the minimum energy state in for a hydrogen atom that can be ionized by such a photon, we need to find the smallest n value where E gamma is larger than that n value. So let's just go ahead and start with the first one. So when n equals 1, of course, this is going to be 13.6 electron volts, since this is our equation here that governs the energy of different states of a hydrogen atom. So let's start with n equals 2. So when n equals 2, we have 13.6 electron volts divided by 2 squared, which gives us 3.4 electron volts. Well, that's larger than E gamma, so that's not the minimum. We need to go to the next one. Okay, so how about when n equals 3? Excuse me. When n equals 3, we have 13.6 electron volts divided by 3 squared. This gives us 1.51 electron volts. Well, this is less than our E gamma value, 2.28 electron volts. So n equals 3 is the smallest state. So we can say n equals 3 is the answer to part A. Box all of this in as our solution, since that is our proof and our reasoning behind that. For part B, it says, what is the velocity of an electron, what is the velocity of an electron that is released due to this ionization? So assuming that the kinetic energy of the electron is equal to the difference between the incoming photon's energy and the energy of that state. So we have E gamma minus E3. This gives us a value of 0.796 electron volts. But to find the velocity, which is in meters per second, let's go ahead and convert this electron volts into joules. So that way we're in SI units. So we convert electron volts to joules by considering the fact that 1 electron volt is equal to 1.6 times 10 to the minus 19 joules. So this gives us 1.23 times 10 to the minus 19 joules. Okay. So now that we have our kinetic energy in units of joules, we can use the fact that kinetic energy classically is equal to 1/2 mv squared, right? Where m here would be the mass of the electron in units of kilograms. So that's 9.1 times 10 to the minus 31 kilograms. So we rearrange this equation to solve for v, and that will be our speed of the electron that we're asked to find. So v would be equal to the square root of 2 times the kinetic energy divided by the mass of the electron. So plugging these values in and using the kinetic energy we just found above, we find that the speed is equal to 5.2 times 10 to the 5th meters per second, or 520 kilometers per second. You could write it as either one. Since there are 10 to the 3rd meters in a kilometer, I'm going to write it as 520 kilometers per second, but 5.2 times 10 to the 5th meters per second would be also correct. We'll box this in as our solution for part B.